Hello, I am Srivastava and my registration number is 17BCE1147. So this is the video of digital assignment 1. In this I'm going to explain about the Liang-Barsky line clipping algorithm. So here it goes.
Liang-Barsky algorithm. So this is basically a line clipping algorithm. In this we write the equation of the line in the form of parametric equations. Here dx is x2 minus x1 and here y is equal to y1 plus t into dy, where dy is y2 minus y1 and t basically lies between 0 and 1. Okay, so it uses these four inequalities. This basically dy and dx. So in this we calculate 8 things, p1, p2, p3, p4 and q1, q2, q3, q4. So p1 is basically minus of x2 minus x1, p2 is x2 minus x1, p3 is minus of y2 minus y1, p4 is y2 minus y1, and then we calculate q1 as x1 minus x window min. X window min is basically the input of the window in which we have to see the line. So like x window min and y window min is the top left coordinate of the window, and x w max and comma y w max is the bottom right coordinate, and q2 is equal to x window max minus x1, q3 is equal to y1 minus yw min, q4 is equal to yw max minus y1. Okay, so now we calculate the value q1 by p1, q2 by p2 and q3 by p3 and q4 by p4. So basically like qi upon pi, where I lies in 1 to 4. So after we calculate this, we select the lines. So if pi is like 0, pi is equal to 0, then it means that the line is parallel to the particular boundary. Like for I is equal to 1, this represents the left boundary. Then I equal to 2 is for right boundary, and I is equal to 3 is for bottom boundary, and I is equal to 4 is for top boundary. So for whichever p value is equal to 0, that means the line which we are going to clip is parallel to this boundary. So after that we look for qi. So if qi for that line is less than 0, then it means that the line is completely outside the window, so we have to completely discard it. Otherwise, if it's like greater than 0 qi, so we clip the line. So how we do that is we have taken here t, value of t, which lies between 0 and 1. So what we do is we calculate the qi and pi for that value, and if pi is less than 0 and so we find out the value of qi and pi, and whichever value, like you will get 4 values, so whichever is the maximum of these of the 4 values, we initialize that value with t1. the maximum value of this. And if pi is greater than 0, we take the particular value of qi by pi which is minimum and we equate it with t2. Then we have a particular value of t1 and t2, and if then we calculate this, the clipped value, which is new coordinate x new, which we have to plot. This is equal to x1 plus t1 into dx, where dx was x2 minus x1 here. Then here y x1 new and y1 new is equal to y1 plus t1 into dy, where dy is y2 minus y1. Then x2 new is equal to x1 plus t2 into dx, and y2 new is equal to y1 plus t2 into dy. So here we have these four coordinates. So x1 new comma y1 new to x2 new comma y2 new. This is the clipped line which we have to plot.
So this is the program for Liang-Barsky algorithm. Here we have taken the input for the endpoints of the line to be clipped. Then this is the coordinates of the window in which the line is to be displayed. And here I've calculated the dx and dy, and here p0 to p3 and q0 to q3. Now this for loop is for checking if the line which is to be clipped is parallel to the clipping boundary or not. So if the value of pi is equal to 0, so it will go inside and check for qi. So basically what here it's done is, if the line is parallel to the any of the boundary window, so it will check for qi. So if qi is less than 0, then it means that the line lies outside the boundary, so we discard it completely. And if the qi is greater than 0, so as you can see, we check if for which side it is parallel. So like here, if I is less than 2, which means I is either equal to 0 or 1, so that means the line is parallel to the vertical axis. So here that means the x is constant. So here what we do is, and as we have already checked if the line is inside or outside the boundary, so we don't need to change the x. So only we check for y, and here if y1 is less than y min, that means if the endpoints of y lies inside the window, so we don't need to change it. Otherwise, if it lies outside, then we change it. And same way, the upper endpoint also we change it if required, and we draw the line. And then this is if I is greater than 1. So I greater than 1 basically means for top and bottom. So that means the y is constant, and we have already checked that the line is already inside the window, so we don't change y and only check for x value. If it lies if the endpoints lie outside the window, we change it to x min, which is the x window min, and we change the x to if the endpoint lies outside the window. Then this was for parallel. Now we check here, we initialize t1 and t2 is equal to 0 and 1 respectively, and then we find out qi and pi. And as we have already checked for parallel, now this is for slant line. So if pi is less than 0, so what we do is we find out this qi upon py, and we assign the maximum value of qi by pi in case wherever pi is less than 0 to t1, and if this pi is positive, we assign the minimum value of qi upon pi to t2, and then we find the value of xx1, which is basically the clipped line, coordinates xx1 comma yy1 and xx2 comma yy2, and we put it in this function line and we draw. So I'm going to run this. So it will ask me the value of x1 comma y1, so I'll just enter 100 comma 100. Then x2 comma y2 I'll give, let's say, 700, or rather 500, and let's say 400. Then x window min, let's just give 150, 150, and then y max, it should, let's give 600, 600. So as you can see, here is the some part of the line is cut, and it's done. Thank you.